Hello friends, my name is Anupam Hore and I am a data science enthusiast. I've been working in the IT industry for the past 15 years now, and I worked in many technologies in the front end as well as the back end, out of which this particular field of data science has always intrigued me a lot. So I decided to create a series of machine learning lectures in order to help those who are new and interested to start their careers in the world of data science. So you can say this particular course is intended towards the beginners. So in this course, particularly, I will try to cover each and every section of machine learning, including the commonly used algorithms, the maths behind the algorithms, and also there will be hands-on experiments after each and every algorithm, so that once you study the maths, once you know the theory part, then we will straight away jump into the practical part of it, how to implement it. So we'll create various models, we'll test our models, we'll compare our models, we'll select the best model for the specific problems. So all those things we will do in our forthcoming classes. The only requirement for this particular course is to have a very basic understanding of Python, because when we will deal with the experiments, when we deal with the hands-on, I will try to do it in Python. We'll create models with the help of Python library. So it is quite important for you guys to at least have some basic understanding of Python. And also, guys, let me know in the comment box if you require a basic understanding of Python. If you guys will let me know, then I can try to cover that as well. Okay, so that at least you guys can start with. And lastly, one important note, and this is for everyone. This is what I have learned all through these years. Okay, this is the way. Whenever I used to take any new technology in hand, so I used to follow this particular methodology. The It is very simple. You need to ask three questions to yourself: why, how, and when. So if you will be able to answer these questions, you will be able to understand the whole concept. And this is for everything, every new thing. This is not only particularly confined to data science, it is in everywhere. So why it is happening, how it is happening, and when it is happening. If you are able to answer this, then you will be able to answer anything and you will be able to understand anything. So we'll do the same thing in this particular series of our lectures. We'll try to reason the concepts and then we'll try to understand them, right? So this is a very small introduction. So now let's straight away jump into what actually is machine learning, and what are the how a traditional software is different from a machine learning software. What are the advantages of having a machine learning? What are the disadvantages? What are the challenges in machine learning? So all these things we will start to understand now in this first lesson, and it will be a very short one. It will be an introduction. So from the next session onwards, we'll really dive into in the details of the various algorithms and how actually we do create models. This particular course will also expect you to learn something about statistics. So I will also cover some portion of the statistics which will be important for this course. Just gentle reminder, guys, this particular course is not intended to make you learn the whole concepts in statistics. This is not possible because statistics is a very vast subject, and so I will try to cover whatever is necessary for this particular course, right? And also in the comment section, where as long this course continues, You let me know what are the topics you want to understand and where you are facing some problems, and I will try to answer them as well. Right. So having said that, let's start. Let me rub this thing first. Okay. And let's start. So, okay. So the first thing we want to understand is what exactly is machine learning. One also important thing for you to notice is that I'm not very good in handwriting. So if you find, I will try my best, okay, to make it readable as possible as I can. But even though if you find some problems, just comment in the comment section and let me know. Okay. So, okay, so let's start. So machine learning. So the very word, when you listen, it tries to say something, right? It tries to say, okay, machine learning meaning machine is trying to learn something. This is the very first thing that will come in our mind. Now, machine, what is exactly a machine? These are nothing but computers, right? Nothing but computers, right? And it is trying to learn something. What is this something? This something is nothing but data. So our whole machine learning depends on data, right? And what actually we are trying to do in machine learning? We are trying to understand our data. We are trying to understand our data. We are trying to find out hidden patterns in the data. And lastly, we're trying to find out a valuable, or we can say we're trying to extract valuable insight from the data. Ultimately, what we're doing, we're trying to predict something. Let's say where, I will come to this section as well, where machine learning is used, why it is used, right? So the whole job is to create a model. That particular model will be trained on this data. So what machine learning does, it understands our data, it tries to find out some pattern in the data, and then it also extracts some valuable insight from the data. Now, what we have written here, a normal human being also can do, right? A normal human being also will be able to do it. So what is the difference in using a machine learning then, right? So the difference is whenever we are dealing with millions and billions of data, in that case, it is very difficult for a normal human being to visualize it with a naked eye and find out the relationship in the data. In that case, when the data is humongous, huge, in that case, machine learning is very handy. There are various algorithms through which we can understand our data, we can find out, or we can make predictions about the data. We can create our models. So this is the main difference. right? Let's understand this with an example. Okay, so let's say we work in a company, and the company wants us to build a spam filter. Okay, so spam filter for emails. Now, what actually are spam? So normally we will classify emails majorly in two categories: ham and spam. The ham emails meaning the normal emails, genuine emails. Spams are basically junk emails. Emails that are coming from any malicious account or from companies who are trying to advertise about their products. So basically what they do is they use bot services like botnet, right, to send a trigger. Basically they trigger multiple emails of the same type to your accounts. So our account have inboxes, right? So ultimately, if you don't have a spam filter, our inboxes will be flooded with this kind of emails. So the original genuine emails, which you want to really know about, will be somewhat lost in those flooded emails, right? It will be difficult for you to identify. That's why most of the mail services like Yahoo, Google, and any other mail services, they have the spam filters enabled. So they create like one more folder as spam, and you can mark the emails as spam. So it will go in those folders, in those directories. From where you can even delete it or you want to keep it, it doesn't matter. But you will be able to differentiate between a genuine email and a spam email. Now there is one more disadvantage in spam emails. For example, the spam emails may contain malicious links, which if the user clicks, it can corrupt one of your softwares in your system. It can play around, it can inject a virus in your system, right? So you see how important the spam filters are. Sorry. So let's say our company wanted us to build a software, right, that can detect whether the email is a spam or a ham. So we took a traditional approach, let's say. So in the traditional approach, we used a language, let's say any language, let's say Java or any other language, and we build a software, basically a spam filter, which identifies that if an email is a genuine email or a spam email. Now, what we will do in those traditional softwares, we basically create rules, right? The logics are nothing but the rules we create, which will identify. So what actually are the rules? So we know in email there will be a from category, there will be a subject category, there will be a body. So the logic will be to detect the email, the from where it is coming, the subject, and also the content in the body. It will compare with the normal emails, and then it will try to find out the difference, and they will write some logic, some complex rules will be there to identify whether these are normal emails or these are spam emails. Now let's say we developed the software, we tested the software, and everything is working fine. So we productionized the software, meaning we made it live. It goes in the market. Now let's say after 1 month, what happens was this group of users who created the spam emails, they changed their logic. They did something. They changed the pattern, and then some change they did, so that our spam filter that is in the production is not able to detect whether it's a spam or a ham again. the problem arises. In that case, where the spam emails will go? It will go again in the inbox because our traditional software is not able to detect properly since they have changed the logic. So what we will do? Again, we will add more rules, right? And ultimately what we're doing, we are trying to increase the complexity of the whole software. Also, we're increasing the lines of code. So every time we productionize it, let's say after a few months or after a few days, this sets of users change the logic of the spam. Again, we have to increase or add new rules. So ultimately, we are increasing the complexity as well as increasing the lines of code in the software, which is very crucial. Why? Because let's say a new guy came in the organization and he has been allotted or he or she has been allotted in this particular software to contribute. Now, for him or her to understand, first of all, is to go through all the logics, the number of lines of code. It's a very tedious job for that particular guy. So it will take time for him to really contribute into this project until he is aware of the all environments that he's dealing with, right? So this is a traditional approach that we will take. Com- in respect to this, let's say, or in comparison to this, let's say if we create a model, a machine learning model, a machine learning model. Let me just wipe out few of the text. So if you need the text, guys, you can just go back in a play and then you can get the text. Really sorry for this. I don't have space here. Give me a minute. Yeah. Okay. So let's say we create a, so this is one approach. Second approach is, let's say we create a ML machine learning model. What we do in the machine learning model is we have various sets of spam emails as well as normal emails. Let's say I denoted normal emails as an E. So there will be various spam emails, examples of spam emails, and various examples of normal emails. This we consider as data. Let's say we feed this data in the machine learning model and we train the model. Then we train the model so that it can classify between spam and normal emails. Once it is trained, we validate with separate sets of data, maybe. And then we find, okay, this model is ready and its accuracy is something that is acceptable. And we launch this particular product as similar to this traditional software that we developed. Once we tested and everything, we productionized it. Similar way, our machine learning model, once it is trained and once it's tested on the validation data, we productionized it. Now it is working fine. Let's say, and also one important thing to notice here is the number of lines of code written in this ML model is way lesser than this particular software because it has various rules also, various logics, whereas the logic is in the model itself for this particular case. In this case, it will be huge number of lines of code. Here, it will be lesser. Obviously, for creating the models, we need to give the right parameters. Now, we need to train the particular model. So for training, there will be some additional research that is required and additional expertise that will be required to create the model. So there can be complexity in that, but not in terms of rules or lines of code. So you see, it is way more cleaner. If a person comes to a company and he's given this software to understand, it will be very easy for him. He just need to know about the model. That's it. So now take the scenario. Let's say after 1 month, or let's say after a few days, this sets of users change the logic. So now a new sets of emails are flowing in the flowing in our accounts. So what we do, we won't change the logic. Here in this case, we are adding rules, right? Here we will not. We'll again take those emails, we'll pass through the model, the same model we have built. We'll again do a training, and then again, that's it. We productionize it. So effort is less, right? Because here we have to write the rules again. We're increasing the complexity. But here, what you're doing, we are just passing the new incoming emails, which are spam, to this particular model. It is trained again, and then it will be ready to predict. Similarly, after a few months, again, if some, let's say some other emails comes, whose pattern is different, again, same training is done. And we are productionizing the model. So maintainability is way more easier in case of machine learning model rather than a traditional software for this particular cases. So this is the advantage of a machine learning over normal traditional approach. Now there are disadvantages also. What are the disadvantages? Disadvantages is like a software. Let's not consider this particular software. Let's say you create a software, okay, and then you tested it, and then you made it live in production, and then that's it. So the longevity of this particular software is for lifetime longevity, because once you have developed it, before making it live, you are already testing it, right? And that's it. There is no problem in it. Obviously, in future there may be few bugs, but you are not changing the entire software, right? You are changing few of the logics that may have gone wrong, or you will enhance the software. You will add new things in the software, but the original software will not change. Whereas in our machine learning models, the longevity is maybe for few months, few days even. We don't know. Why? Because our machine learning model depends on data. Because our training is done on the data, whatever data we have. If let's say in the forthcoming years, the pattern in the data change, then the model will behave erratically. The accuracy level will come down. So the main difference is normal traditional softwares. So let me just erase few things. Just give me 1 minute, guys. So the difference is normal softwares never degrade, whereas machine learning models degrades in due time. And the reason for is change in the data, because our whole model is based on data. If data is changing, obviously our model will not work properly. So this is one of the disadvantages of machine learning. Now, let's try to understand the challenges. Let's try to understand the challenges in machine learning. So, what are the challenges in machine learning? One of the challenges I have already discussed in the previous slide, where you need to again retrain the model if the data changes its pattern. This is one of the challenges. Second challenge is to have so the whole machine learning depends on data, right? So data is crucial, right? So if the data doesn't guarantee sanity, then there will be a problem. Our models will not be accurate, right? So data sanity is important. Now, whatever also the in the data, there will be various features. Okay, input features. I will come to this part, guys. For now, just understand that there in data, there are input features, there may be output features. Now, what are input features? What are output features? I will come. Normally, output features is something that we are predicting through the model. And we are using the input features to train. Okay. So I'll come to this particular section, but for now, understand that the data in the data we have inputs and output features. Maybe there are few input features which are very important, but they're not described properly. And in building the model, we ignored some of the features. Maybe those features are important, but we didn't consider them. So what will happen? The model will not give us good accuracy. Why? Simply because we haven't considered the features. And why we haven't considered the features is like we didn't know about the data. So data understanding. So if there is some problem or some leakage in data understanding, then there will be problem in model building. So these are few challenges that we normally face in machine learning models. And there are other challenges as well. I will come to them one by one when we go along with the course. Okay. So there are like outliers. There are so whenever we are dealing with data, we should be 100% sure the data is cleaned. If the data is not clean, then the models that we will build with the help of different algorithms will not give us better accuracy, and ultimately we will not be able to solve anything. So machine learning is what? Machine learning is to solve a problem statement. Business may have a problem and we are solving the problem. So this is all about machine learning. So this is the first introduction about machine learning, guys. And I will start with different algorithms, what are there in machine learning in my upcoming lessons. So feel free to comment anything. So this is the first tutorial. So I hope you may like it. If you have any suggestions to improve the quality or to go in the depth, or you have anything to know more about it, just write in the comment section, and do subscribe my channel. Thank you, guys.